Right. Hello. All right. Okay, there we go. Got that. All right. Okay. Here online. All right. I am here. All right. We'll wait for a couple of minutes here, and then we'll go ahead and get started. Oh, wow. A lot of people follow me. It's really kind of them. Okay. I'll take that. Hey, Cathal. How are you, my friend? Thank you. Thank you. Thank you. Two plus two, quick. uh, two to the fifth. Two to the fifth is 32. Hey, love you too, my friend. Love you too. I hope you're well. I just hope you enjoyed. Hey, no, man. I I do it for the love, and I appreciate your kindness to me. I'm not sure if I deserve that, but you try to give. I try to give back as much as I get. So it's only a fair. I'm not made of like super flow amount of cash, even though it looks like it, but I support those who I believe in. So, well, that's fine. That's not a problem. How's my audio coming in, Cathal? I hope my audio is coming in okay. I've been really tweaking around quite a bit just to try and see if I can get things going. Hmm. Let's see. I'm gonna wait a couple minutes here, but I'm gonna go grab a drink and then I'll be right back with my big old chug of water. All right, be right back. Hey, there you are, Brenton. How are you, my friend? Grab some water there. Yeah, there should be a stream delay if the audio's good and it lines up okay. Hey, Dr. Dan, how are we? How we doing? Good. Well, I've been having some issues, so I decided to do a little bit of a delay and make sure that my audio lines up with my mouth. Otherwise, there have been some videos I've seen where that wasn't the case. by no means am I running a perfect shop here, but at least it's working consistently, and that's all I can really hope for. I'm doing good, my friend. I'm doing good. It's been a very nice day so far. What a weekend, right? What a weekend. I think everybody can say that as a very big weekend. Yeah. All right. Oh, actually, should also turn my fan on. Hang on a second. Let's get right into the maths. You got that right. All right. Okay, we're gonna get right into it. So, if I recall correctly, let me make sure here. Give me a reminder. Uh, which section did we leave off at? Was it? Did we leave off at like section 4.5 at the end of chapter 4, or did we leave off at the middle of chapter 4? Because I know I know it was one of those two things. It's just a matter of which one I decided to do on Wednesday there. I left at 4.5. Okay. All right. So I did end it. I did end chapter 4. Okay. Cool. Not a problem. Not a problem at all. 4.5. That's fair. That's fair. That's fair. All right. So we're gonna get into. No. You know what. Actually, yeah. Let me. Hang on a second. No, that's a fair question, Jasmine. Very fair question. Okay. Let me do this here. All right. Okay, let's get started today. Welcome back to Monday. Hope you have a nice weekend. All right, so to answer your question, there, Jasmine, I'm going to first and foremost apologize to everyone here. I just overslept. I ain't gonna lie. I'm not gonna make up excuses. I just overslept. I woke up at like 12 o'clock, and I was just I don't know. I was just gone until 12 o'clock, and then when I woke up, I was like, oh no, I was supposed to do a class at 10, and I was like, oh man, I felt terrible. I felt really bad that I didn't come on Friday. So that no, I still want to make up that class. Yeah, that is 100%, 1000% my fault. Okay, so um, I need to first be transparent and apologize to everyone in regards to that because I did say I would do that. So, yeah, apologies about that. I know that's not a normal thing for me to do, and I don't like breaking promises because I know how important they are to you. So, yeah, we're gonna definitely do this week a Friday class at 10 o'clock if you're okay with that. Let me ask that again. Are you guys okay with doing a Friday class at 10 o'clock? I want to get a poll here from the people before we get going here today. You guys okay with the Friday 10 o'clock class again? This time I promise not to oversleep, sort of deal. No problem? Okay, great. Okay, wonderful. Okay, so let's go ahead and if all right, so let's go ahead and get started here with the first few sections of chapter 5. Yes, all right. So we're going to get started here with the first few sections of chapter 5. All right. Now chapter 5 here is going to be all about measurement, okay? So that's what all of chapter 5 is going to be about. And I'm going to bring up a couple of things here. So let me go ahead and bring got it. Some things to do. It's an this is a bare bones operation here, right? Yes, to webs work for me. I pay you money to work. All right. All right, let's do that. You say, fair. That's that. Now that's perfectly fair. You guys have every right to ask me at any time, so I do not mind at all whatsoever. Let's grab the e-text here, and we're going to talk about a few things here that are going to be very important. Now, um, so, yeah, we'll see you in the hash chat there, Cathal. I really appreciate you coming out, buddy. Thank you so much. You're super kind. All right, let's do 290. All right, so all we're going to be doing here is we're just going to be dealing with, again, measurements in some variety. All right, now in this section here, they do talk about, and I believe they do, and I want to be double extra sure that they do here. Okay. All right. So the what we want to do here is we want to talk about first. Gosh, I need to do one thing here. Sorry, everybody. Up here. So the first part of this does talk about significant digits, and I'm not going to really talk about that too much here. I'm just going to mention it and just kind of move on. Significant digits are used in some questions, particularly in this particular section, section 5.1. So I at least talk about it here just briefly. So you may hear the term significant figures or significant digits. I'm going to reference you to a page here. Refer to page 281. Um, there's some things in regards to that, more so along the lines of, you do talk about, how, are the zeros significant? Are the zeros not significant? Most of the time, though, to be as realistic as possible, we want to look at a situation where we want to round to a certain decimal place. That's the more realistic situation. So the idea of significant digits is okay, but in reality, for what we actually use numbers for, is it that important? No, not at all. It's really what you want to round to in the context of the problem that actually sees a lot more importance. If you're dealing with dollars and cents, for example, then you're only going to go to two decimal places, okay? That just makes perfect sense. You're not going to round to like 7 decimal places unless the context asks for it, all right? So, uh, that's really one of those things that why I'm not focusing on it too hard here. However, in this section here, it does talk about two other important concepts, things that are certainly applicable to a technical field or heck, even a everyday sort of thing. And that talks about precision and accuracy. Now, typically when we think of precision and accuracy, we kind of think of them as interchangeable parts in terms of a definition. All right. All right, so but the precision here is basically a measurement number that is indicated by the in this case here, precision would be the measurement number that's indicated by the rightmost significant digit. So basically, this is basically saying, okay, if you go out to thousands, basically round to round to 1 decimal place. Um, you know, thousands. Okay, round to the thousands. Okay, it just depends on what that precision is going to be. Whether you round to the thousands, or whether you round it to tenths, or whether you round it to 100 thousandths, whatever the context asks for. That's what it is. All right. All right. Accuracy is the measurement number referring to the number of significant digits. Now you're probably saying, well, you didn't place a whole importance on significant digits, so why would you mention this? This is basically saying how basically refers to, i.e., how many numbers do you write out to be as accurate as possible. So the question is that would you write, for example here, would you write 38,000 or 37,983? Okay, so which one is more important to you in the context here? Is it going to be 38,000, which would have less significant digits or whatever? Would you round it off to per thousand, or would you put it in all exactly the amount here of 37,983? Which one is more important to you? So again, that's dependent on what you're studying or what you're using it for. Again, if you have an opportunity to round to the nearest thousand, then you do that because again, you don't really care too much about the accuracy. Or if you really care about the accuracy really a lot, well, then you're going to go out as far as you can to the maximum number of maximum numbers in order to get the super accurate count of whatever you're doing, whether that be a dimension or whether it be counting items or anything of the like. So just depends at the end of the day on, of course, once again, the context. Okay, so we have accuracy and precision there. Again, fairly important. There's also one more thing here to mention here in this section, and this one's more of the technical side. There's tolerancing. All right, so I think tolerancing, if you've been in the technical field, tolerancing is basically again the plus or minus give. So is basically the plus minus give for a certain dimension. So it's like, okay, you can say give or take. Say, oh, he has, a 15-inch pizza, give or take a tenth of an inch. Okay, so that would be a tolerancing. That would be acceptable for a, say, 15-inch pizza or whatever. Okay, so again, that would be something that you could take to the bank there and be like, okay, and in dimensioning and technical stuff, you could have a print, for example, and they would have dimensions like, okay, it should be 1.5 inches, but because machines don't do things that are super precise to say 1.5 inches exactly. It could be off by just a little bit, but maybe you have a strict guideline about how off that could be. Maybe it could be off by, give or take, a thousandth of an inch. Okay, and then that would be your tolerancing. So then you would check that. It says, is it within a thousandth of an inch? Okay, great. It passes inspection. Okay, wonderful. All right, so that certainly plays into that as well. Now, one of the most important things here in this particular section is going to be understanding units. So one of the big keys here in this entire chapter is the key here to this chapter is going to be converting units appropriately. If I can spell, let me know. Uh, no. Approximately no. Appropriate. There we go. All right. All right. So we're going to be looking at examples of how to convert units as well. So we're going to want to read these problems here very carefully. All right. So I just want to point that out there so it's not like, oh, you didn't come from nowhere. No, we're going to look at these problems here very carefully. And, this section has a few, but we're going to go with a few more things here as well that talks about that. So let's put on the just checking something. Okay, no. All right, fine. All right, let's look at some problems here, and let's see what we can get. Okay. All right. All right. So looking at some problems here, let's take a gander at what we're going to be doing here. All right. So this section here by itself isn't going to be too long. So, all right, let's look at number one. It's Specifications call for drilling a hole 0.637 plus or minus 0.005 inches in diameter. Will a 41/64 inch of a hole be within the required tolerance? All right. So here for number one. All right. Let's take a look at that there. What do you think we should do first if for number one there? What do you think would be a good idea here for number one? What should we check first in? Okay, perfect. Okay, convert the 41/64. Totally agree. All right. So 41/64 is equal to, what's that equal to? I don't know. So you guys, why don't you guys tell me? 41/64 is equal to what? What's that as a decimal? 0.641. Okay. So 0.64, just 0.64. All right. So here's one thing that you want to do. All right. So let me go ahead and talk about this here for just a second, because I think this is still, this is still rather important here. So one of the things that I do want you to do here and make a good habit of is 41/64 is going to be 0.640625. What I do not want you to do is do not round in the middle of the problem, okay? So do not round in the middle of the problem. All right, you want to make sure that you have as many numbers as possible because, again, we're dealing with specifications that go out to thousandths of an inch. So even if that's 0.641 or something like that, I don't want to round because, again, I want to just be extra sure that it falls within, if it does or does not fall within those specifications. That's going to be really, really important here. Okay. The only time you round at the end of the problem is at the end. So whether you can say, in this case, it's a simple yes or no question. But again, we want to keep things as accurate as possible, so that way we can see exactly if it is indeed true or not. Okay, so just be a little careful about that. It tends to be one of those things that you have to be a little vigilant about. Now, specifications here. Um, Specifications here call for drilling a hole 0.637 plus or minus 0.005. So what we need to do is we need to find out both sides of the coin here. We need to say, okay, hey, I want to find the dimensions here. All right, 0.637 minus 0.005. And we want to find 0.637 plus 0.005. Okay, so let's find out each of them and see where our tolerancing dimensions are going to be. So what about 0.637 minus 0.005? What's that going to be? .632, okay. So far, so good. All right. And how about 0.637 plus 0.005? 0.6365? I think you added an extra zero there, Jasmine. Think you had point triple zero think you had 0.00065. Yep, 100 there. So 0.642 is correct. Okay, that part is definitely correct there. Oh, that's okay. That's okay. That's why that's why I'm here to point that out. No problem. No problem. It's all good. It's all good. It's all good. Okay, so does 41 over 64 fit within this tolerancing? Is it between 0.632 and 0.642? Yes. Okay, that is correct. So 0.640625 is definitely between 0.632 and 0.642. So if I were on the manufacturing floor, for example, this would definitely be passing inspection. Okay. All right. Any questions about that? No? Okay. Very good. All right. Let's go ahead and take a look here at the next one. Okay. All right. Let's look at this one here. Okay, so let's look at number 4. What size wrench to the nearest 30 seconds of an inch will fit a bolt with a 0.748-inch head? All right. So let's say you're trying to find a wrench and you're trying to do the thing with the wrench and all that stuff. All right. Well, how do you know which type of wrench will fit the bolt the best? Okay. So for this particular question here, it's actually not as tough as it may seem. Again, you're trying to say, well, 30 seconds of an inch, like what? Now you could look at that chart. We had a chart like a while ago, and if I recall, and it's like, okay, the chart had like 30 seconds of an inch, 64ths an inch. And you can go ahead and figure that out, and that's you go ahead and take a look back at that chart here. But there is an easier way to go ahead and approach this type of problem here. What page was that on again? Yeah, let me check that. Actually, it's a fair question. It was that was in chapter 4 here. So I believe that was chapter 4. Either that chapter 4 or chapter 3. Yeah, maybe it was chapter 3 actually. But let me reference back to that. Trying to find that page. I know it was not there. No, it's not there. I think it's here. That was on page. Yeah, there we go. That was on page 168. Okay, page 168. There you go. So if you want to reference that again, that's perfectly fine. Yeah, no problem. I'm here to help. Okay, so, but I'm going to just show you another way to kind of help you kind of do this type of problem here. So probably one of the easiest ways we can do this problem, just sans the chart. If you don't have the chart with you, it's not a big deal. But we can take 0.748 here, and we're going to multiply that by 32. Okay, so we're just going to multiply it straight up by 32. Okay. So let's go ahead and multiply this by 32. I'm going to use a calculator here. Phone, because my calculator is dead. How nice. All right. So times 0.748. Right. All right. So if you do this out here, so as you can see here, we get 23.936. All right. So what would be the nearest 30 seconds of an inch? All right. Okay. 15 over 16. 15 over 16 here. So it'd be 30 over 32. I want 30 seconds of an inch here. Oh, for a 0.748 inch head. So here, I'm going to approximate this to, this is about 24 inches. Okay. So what I'm going to have here is I'm going to have 24 over 32, which then can reduce to 3/4. Yeah, 3/4. Equal to 3/4, 3/4. Now, are there any questions about that so far? No. Okay. Now, I do want to actually point one thing out, though. This is actually going to be very important. What if, for example, here, okay, what if, for example, here, we were to get, say, let's say our answer here was 23.444. Okay, let's say that's what we got here. What would you put this to be? If you got 23.444, right? What would be your nearest 30 seconds of an inch? What would that be? Hmm. Okay. Now I do like this. I do like that guess there. 23 over 32. And you're just like saying, "Well, is it 23 over 32?" The answer to this is not exactly. They're probably saying, "Well, wait a second here. Why is it not 23 over 32?" In fact, this is once again going to be 24. You're saying, wait a second here. I would normally round down here, instead of rounding up. In this case, I want to round up here. And I want to show you why. The reason why we're going to round up here to 24 once again is because if I'm choosing a wrench here to have some kind of random bolt here, that 23 over 32 would be too small to fit that bolt. I would need something that would be slightly bigger that could fit over that bolt and then tighten it up. So again, the context of the problem here is a big factor here. In this case, regardless of whatever you get over 23, you're kind of forced to use 24, so you have to round up here in this particular circumstance. So this is one of those questions that it's really easy on paper to do, but one of the important concepts that we want to talk about here is that sometimes the context is going to force you to actually just go one direction here in terms of, say, in this case, rounding up. So I did want to point out that distinction here in this problem, albeit it's not hard. And again, I'm not pointing out that it's going to be super duper hard. What I am pointing out here is that watch the context and read the problem carefully into determining what that final result's going to be. Okay. All right. Just want to be sure that everybody was pretty clear with that. No problem. Yeah. So context means a lot. we did talk about at the beginning of the semester, but now you can see where it's starting to play even a bigger role than what we've been doing from before. Okay, let's go ahead and take a look here at the next section. All right. All right. So the next section here that we're going to be talking about is going to be talking about next section here we're talking about is talk about U.S. customary units. Oh man, ooh, baby, U.S. customary units. All right. So everybody should be familiar with U.S. customary units to some degree. Um, Now, those of you who are familiar with U.S. customary units, we're talking feet, we're talking inches, we're talking yards, we're talking miles. We're talking all those guys. Now, one thing that I'm just going to strictly point out here is we have a little chart here, and there's a lot of things here on the chart. I'm gonna reference a page here. It talks about area and volume and height and distance and all that other stuff. So we have a chart here on page 308. Okay, so here's a chart here on page 308 that has a bunch of conversions, many of which you are already fairly familiar with, and then some of them which are going to be definitely brand new or have not used whatsoever. So if you're good at cooking, then the liquid capacity stuff is going to be pretty easy for you. I'm not good at cooking. All right, zero, zero. All right, but like 1 yard is 3 feet, 36 inches. Okay, 1 foot's 12 inches. A pound is 16 ounces. A ton is 2,000 pounds. Okay, area. Some of these you may have never used before, and that's perfectly fine. Time is really easy. I think everybody knows time. And then some of these other ones that you probably haven't used too often, like volume, cubic feet to cubic inches, and so on and so forth. Okay, so now, am I expecting you to memorize these? The answer is no. Okay, it's not realistic for me to go ahead and say, you know what, you should know all of these by heart. Like, of course not. What we all want to do here, and probably the most realistic thing that we want to do here, is to go ahead and be practical about how we use these. As I mentioned here in the key here for this chapter here, um, the key here once again, and let's at least talk about here, is to convert the units appropriately. So this is a way we're going to want to convert from one set of units to another set of units. In this case here, though, this just happens to be between the U.S. in our regular old U.S. system here. Now, the unfortunate part is the U.S. system is only used in a few places, like ever. So um, maybe 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 the U.S. and Liberia and maybe the other territories of the U.S. like Puerto Rico, Guam, U.S. Virgin Islands. Okay, places like that will use the U.S. system. Otherwise, most other places they'll just use the metric system, which we'll talk about as well. So, um, yeah, the metric system. Yeah, the metric system, so good. All right. Anyway, all right, but let's take a look at some problems here, and we're going to use these conversions here, and we're going to go ahead and see what we'll get out here. All right. This is one of my favorite ones here. So let's do this one. All right. So it's going to be number 5. Number 5 says the earliest known unit of length to be used in a major construction project is the megalithic yard used by the builders of Stonehenge in southwestern Britain in about 2600 BC. If one megalithic yard is equal to 2.72 plus or minus 0.05 feet, convert this length to inches. Okay, so we want to find out how big a megalithic yard is going to be based on this, based on what a megalithic yard is defined as. And so here's the question: what should we do first here? What do you think we could do first? What do we do first here? What do you guys think? try and put this up here. Find the measurement based on the tolerance given. Very good. So we have 2.72 plus plus or minus 0.05. That's right. So let's find out what we get here. We get 2.72 minus 0.05 and 2.72 plus 0.05. Let's find out what each of them are first. Okay, so 2.72 minus 0.05, what's that? .67. Okay, good. All right. And how about the other one? 2.72 plus 0.05. 2.77. Spot on. All right. Okay. So what are we going to do next here? Okay. All of you doing really well so far. So we have 2.67 to 2.77 feet. Since it's not a precise science here, since we're dealing with approximate megalithic yards and how they defined them back in the day. So what should we do next? We want to convert these into inches. So what should we do? How many inches in a foot? 12. Okay. So there's 12 inches in a foot. Now what should we do next then? If there's 12 inches in a foot, I have 2.67, for example, feet for the low end. So what should I do there? What do you think? Hmm. Hmm. 2.67 divided by 12. Okay. Now, I like this answer for a couple of reasons. Now, unfortunately, that's not the correct answer, but that's not really the important part here. I think that it's important for us to at least take away the guessing part here as terms of what we want to do in terms of putting it in inches. Now, let's talk about that part here. Okay, so I'm glad that this came up here because I do want to talk about the second key here in this chapter because there is definitely more than one key that we want to focus on here. So key number 2 here, and what I'm going to show off here, is what we want to do here specifically is we want to cancel out units until we have the units we want at the end of the problem. Okay, this is going to be key number 2 here of what we're going to look at here entirely within chapter 5. Now, how does that work exactly in this context? Well, let's take a look at let's go ahead and bring up my paint tool here once again. Okay, and I think this one will be pretty appropriate for the paint tool. So let's take a gander here at this one and let's see how we can met this out. Okay, so what I'm going to state here first is that we are given here for the first dimension is 2.76 feet. Now let's not forget what we want here. What we want here is inches, right? So what we want here is inches. Now, as was correctly stated, there are 12 inches in 1 foot. So if we go with the idea that we want to cancel out the units we have until we have the units we want. Now we want inches here. So the way to take away the guessing game out of this is to say, okay, if I have 2.67 feet, I don't want feet as a unit anymore. All right, I want to get rid of that altogether. I want to say goodbye to the feet units. Okay, so I'm going to put here 1 foot, and I'm going to put 12 inches on the top, and I'm just going to multiply that. Okay, again, I don't have to guess where inches go because I want inches left over here. But see, let's take a look at what happens here. Inches is left over, but what about the feet, right? I said, hey, I want to cancel out those units. Okay, well, I have feet here on the top, feet here in the numerator, and I got feet here in the denominator. So now I can cancel out those units outright, just like that. And that just leaves me with the inches that you see left over, just like so. So albeit this is a, simplistic example, this takes away the guessing part about if you have to say divide 12 or multiply 12. This is actually going to show you physically, you can see it with your own two eyes and say, oh, okay, I got to put the number up here because I want to cancel out these units and convert it to that. That's going to be the big thing that we're going to be doing here in this chapter entirely, right? Is just being able to go ahead and just take out these units one after another until we get what we want. So as you see here, we have 2.67 times 12, and then inches is going to be our units that are left over. And we could just go ahead and simply do that out. So, oh, this works again. All right. And then so here we're going to get 32.04 inches. Okay. And that'll be our final answer for that problem. Great. Are there any questions about that so far? I just want to be, I want to be on the safe side here and say, hey, I got 2.67 feet. I convert that over to inches and be like, all right, cool, no problem. Let's try 2.77 feet, and we're just going to do it the same way. Okay, we're going to do it the same way. Nothing too different here. And here again, we're just going to put 12 inches and 1 foot. And again, as you see here, the feet will cancel out and just leave it with inches. Again, just want to take away the guessing part. I'm not a big guesser. I'm just like, I got to do it. But if I got to do it, I want to make double extra sure that I know what numbers need to go where. Okay. So this is our answer here. 32.04 and 33.24 here is the approximation of 1 megalithic yard in inches. Any questions about that? Okay, let's take a look at some more problems here so that way we get more comfortable with the idea of converting things over. Okay. Sure, I could wait. What question do you got there for me? Or if you want me to bring up the notes, then sorry about that. Just stop right there for a second. Yes, because it was there are two answers because in this question here, let me go back to the question. We wanted to convert this length here in inches because it was plus or minus 0.05 feet. So it's a range there, Jasmine. So the range of a megalithic yard in inches is 32.04 inches, 33.24 inches. Because we found okay. So I just want to be sure that it's pretty clear about that. Oh, yeah. That was just the problem that it asked us to do. All right. Let's take a good look here at this next one. All right, this one here, again, rather important. So, number 8. Cast aluminum has a density of 160 pounds per cubic foot. Convert this density to ounces per cubic inches and round to 2 decimal places. Okay, so let's start off with what we see here. And this is a simple conversion problem, but that's okay. So let's at least take a look at what we have and what we want. All right, just looking at this problem here. So we have 160 pounds per cubic foot. So the way we're going to write it out, we're going to write it out like this. We're going to have 160 pounds. So we're going to have 160 pounds on the top per, which will be just this big fraction, per cubic foot on the bottom. Now, if you need to, just remember what we want here at the end of the day. If you want to write this on the side, that's fine. What we want here, you don't have to do that part if you don't want to, but you want here specifically ounces per cubic inch, okay? So you want ounces per cubic inch. So let's not forget here, okay? We want ounces on the top and we want cubic inches on the bottom, all right? So ounces in the numerator, cubic inches in the denominator, all right? So let's do it one piece at a time using the conversion table, all right? And we're just going to see the steps we need to take in order to convert it into these 2 units respectively. So first, let's talk about pounds. Let's change pounds into ounces. So, how many ounces are there in a pound? "16 ounces." Okay, good. Now, where should ounces go? So we're going to put ounces here. Should ounces go on the top or should ounces go on the bottom here? That's right. Think about what you want. Look at what you want. What do you want here? Do you want ounces on the top or do you want ounces on the bottom? And what do you want to get rid of? All right, if I put pounds on the top, then I would have pounds on the top and pounds on the top. That means I can't cancel the pounds out, right? I know that's still confusing, but think about it this way, right? I want to cancel out those units. So it's like I know that 16 ounces equals a pound, okay, just based on the chart we have there. And that's fair. Absolutely. All right. But again, I want to eliminate pounds here. So I know that ounces I want on the top, so that means that ounces should be here on the top. That forces pounds to be here on the bottom. I just have 1 pound and 16 ounces. Again, I just want to eliminate the pounds here, just like so. So again, I want ounces on the top, I want cubic inches on the bottom, okay? Because again, I want to eliminate pounds and I want to just have ounces on the top. All right, let's try the other one here. That's fine. That's fine. Again, we're going to go through this slowly here so we can get used to this. All right, I have cubic feet here on the bottom, and I want cubic inches on the bottom. Okay, well, first of all, we need to find the conversion. How many cubic inches in a cubic foot? How many cubic inches in a cubic foot according to our chart there? internet being bad. Shame on you, internet. My face is going so slow. Okay, let's try this again. I know. My connection is notoriously just, man, it's just wonky. I just don't know why. It's so weird. It's so weird. I just don't know. I've tried like everything under the sun, and it makes no sense. Yeah, stupid condos indeed. I'm a one man crew. I can only do X amount of things. So maybe it's just maybe it is like just sharing connections with the condo and stuff. So can't do much when it's like that. If I had my own house, house per se, then yeah, I guess it could be a little different. But I ain't gonna say nothing. I'm very I'm very um I'm very blessed to even have this place for myself. So um I ain't gonna complain. Content. All right. I think it was said earlier. All right. So we had 1 cubic foot equals 717.28. So 1728 cubic inches. Okay. All right. So 1 cubic foot is equal to 1,728 cubic inches. Okay. So let's answer this question here. Maybe this will be a bit easier for you guys. Okay, so let's answer it this way. Where should cubic feet go? Should cubic feet go on the top or should it go on the bottom? Okay. Cubic feet should go on the top. That's correct. Because then we'll have 1 cubic foot here on the top and we'll have 1 cubic foot here on the bottom. We'll be able to cancel out those units. That forces the 1728 cubic inches to be on the bottom. Okay, so let's take a look at what we have here. We have ounces on the top, which is what we want. We have cubic inches here on the bottom, which is also what we want. So we got the two units that we're looking for here. So putting this together here, we're going to do multiply straight across. We get 160 times 16. That'll be in ounces on the top. And then we're going to divide that by 1728. And it'll be cubic inches there on the bottom. Okay. So, of course, I do expect you to use the calculator for that. All right. No question. Okay. And so if we round to a couple decimal places here, we're going to get 1.48 ounces per cubic inch. All right. Any questions about that? I want to be sure that you guys understand the reasoning behind why I put the numbers where I did. So that way it's a little more clear about um, why I chose things in a certain way. Okay, great. That's what I encourage you to do, Jasmine, is just for you to write it down, and then you can again physically see what you need to do in order to convert it to those units. You know, I'm a visual person. I need to see it in front of my eyes. So, or even if I'm like thinking about a problem here, I kind of imagine it as a picture in my head. So, I'm like, hey, I got to see that, you know, and I got to be able to know what boom, 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 where stuff goes. So, yeah, totally understand that. All right, let's try. Oh, appreciate that. I mean, that's how I learned is try to break it down into something easier because I had a hard time just trying. The toughest part about math is because it's kind of like a different language. Um, it's easy to not only to confuse yourself, but it's like if I need to, I need to make it easier on myself. And how do I do that? I need to break it down to the parts where I can understand it as best as possible. I had a hard time. Like in junior high, I had a long hard time just getting that part. It's like it, when you look back at it, of course, you can say, "Wow, that was so super simple." But when you're doing it at that moment in time, you're just like this is all like foreign to me. This is like 10,000 things coming at my brain at once. How do I make this easier? How do I make this simple? How do I know what this looks like? Because if I got to transfer from hand to paper, okay, I need to be able to put it into context that I understand. On a personal level. And then let's say, well, now I think about it and it's like, okay, well, how do I make other people understand that, on their personal level? We'll break it down to its most fundamental parts, like I did. And it's like, okay, let's just build it up from there. And then it's becomes a lot easier after that, and the more you practice, of course, with it and whatnot. So, I mean, that was like kind of my personal evolution through math. It was not by any reason was it not easy, but I will say this: it really helped out a lot to fail quite a bit, at least from my point of view. It helped me a lot to fail quite a bit because then I understood, how tough it can be for a lot of other people, you know, um, who are understanding that same thing. That's why I don't want to talk like, 10 levels above you. I want to talk at your level, as much as possible. So, all right. Yeah, no problem. I'm always here to help as much as possible. All right. Let's look at number 18 here. This is check if this is the. Yeah, I think that's the. Okay. Yeah, let's do that. All right. So number 18. In the petroleum industry, a barrel is defined as 42 gallons. A scientist wishes to treat a 430,000 barrel oil spill with a bacterial culture. If the culture must be applied at a rate of 1 ounce of culture per 100 cubic feet of oil, how many ounces of culture will the scientist need? Round to the nearest thousand. All right. All right. So there's a big oil spill, and well, unfortunately for the environment, that's really bad. All right, but okay, what do we want to do here in this case? We want to find out how many ounces of this culture that we're going to need in order to hopefully clean up this nasty oil spill. But what do you think we should do first in this problem here? What sounds like a plan? Let's answer this question here. Let's just go once. See, yeah, let's see how many gallons we got, right? I mean, we don't know how many gallons we got. We have some amount of gallons in the sea, unfortunately. Um, Obviously, we don't want that to happen, but in this circumstance, that just happens. So we have again, how many barrels do we have? 430,000 barrels. So we're given here 430,000 barrels of oil has accidentally spilled into the sea. And we're given the special conversion here that 1 barrel is equal to 42 gallons, which is definitely true. Okay? They actually do figure it out to be 42 gallons. So anytime you hear gallons of gas, or barrels, then that's exactly what it's actually equal to. Now I'm going to put this over 1 because just so we can have fractions every go around. So all right. So I need to multiply this. I need to figure out how many gallons here, as Jasmine has correctly pointed out here. So what should I put on the top here? What should I put on the bottom? Let's go with the bottom here. Where should I put barrels? 1 barrel is 42 gallons. So where should I put barrels? Should barrels be on the top or should barrels be on the bottom? Barrels should be on the bottom. That is correct. Okay, good. That way we can go ahead and cross out the barrel units just like so. And that forces us to put gallons here on the top. So now we have the number of gallons, okay? Perfect. So far, so good. And we do have a lot more to this problem, though, so we're not quite done just yet. But at least we have a good start. Okay, let's keep going here, though, because we do have a little bit more. Now, we do have a bacterial culture here that says, okay, we need a rate of 1 ounce of culture, okay, for every 100 cubic feet of oil. Okay, so let's go ahead and write that down here. We need 1 ounce of this special bacterial culture for every 100 cubic feet of oil that we have here. Okay, so this is a special conversion given to us here in this problem. Okay. So right now we have everything in terms of gallons, but maybe we need to put it in cubic feet because we're going to need to know how many ounces it's going to take for the amount of cubic feet we got. So how do we convert gallons into cubic feet? What's the conversion for that? Take a look at the table there. 1 gallon is equal to 231 cubic feet. Okay, so all right. Again, I'm not asking you to memorize this. I'm just asking you to go ahead and use it. So okay, now that we have this conversion here, let's multiply again. Now let's answer this question here. Should gallons go on the top or should it go on the bottom? gallons go on top or should gallons go on the bottom? The table says inches. Let's take a look here. Let's take a look at the table here again. Oh, okay. Maybe we need to use a different one then. Okay, let me take that away here. Do we have any gallons? Yeah, you're right. It does say inches. So let's write down the other conversion here. Are there any conversions to cubic feet and gallons? Take a look at the table here. There is one other conversion there from cubic feet to gallons. Yeah, that was inches there, so that's my fault. Okay, 7 point. All right, so let's write that down. It says 1 cubic foot here equals 7.48 gallons. All right. I'm just going to use this conversion here. That's what's written on the table. 1 cubic foot is somehow, some way, 7.48 gallons. All right, fine. Seems fair. Okay, but let's answer the question again here one more time. Where should I put gallons? Should I put gallons here on the top, or should I put gallons here on the bottom? Okay, right. I already have gallons here on the top, and I want to eliminate that variable. I want to cancel it out. So I want to make sure that I have gallons here on the bottom, specifically the 7.48 gallons that I'm looking for here. So the gallons can get canceled out, and I have 1 cubic foot here, just like so. All right, so far so good. Okay, now we can go ahead and use our last conversion here, which is the special one that we're given in this problem here, is that 1 ounce of this special bacterial culture is equal to 100 cubic feet. So where should cubic feet go, top or bottom? Yeah, once again, the bottom here, right? We want to be able to eliminate the cubic feet as a unit, so, and just have ounces of whatever culture is left over. We're going to take away that and just put 1 ounce on top. Now we're going to see what we get here. Now, let's go ahead and put it all together finally. We're going to have 430,000 times 42, that's here on the top, over 7.48 times 100. Now, one very important thing is you need to be very careful about how you enter that into the calculator. If you don't put parentheses around the bottom, then what will happen is it'll do 430,000 times 42. You'll divide by 7.48, and then you'll multiply by 100, and you're going to get a very, very large number. So you actually want to be sure you put parentheses in the appropriate places once you go ahead and do put that together. So you have 430,000 times 42, and then I'll divide it by 7.48 times 100 in parentheses. Okay, can anybody tell me what they got for their answer? I want to be sure that you guys entered this in correctly in your calculator. So, hence why I'm asking. 2414.439. Okay. $24.14. Let me check that. I think you're missing 10 from the top. I think you put you're supposed to put 430,000 there. All right, Brenton got that. Okay. Yeah, Jasmine, I think you're just missing I think you put 43,000 instead of 430,000. Yeah. Yeah. Breton, make sure you put parentheses, okay? Parentheses, underneath 7.48 times 100. That's okay. It happens. So, Brenton, why don't you try that again, okay? I want you to be sure here. I want to see what answer you get here, because that's too large of an answer. So you're trying to do everything all at once without the parentheses. You need the parentheses there. All right, try one more time there, Brenton, and tell me what you got. Okay. Brenton, can you tell me what you got there for yourself? Just want to be sure that you got that typed in okay. Wait for that for just a second. He's getting that in. All right, I'll write down the answer here in the meantime. Hopefully you get this answer too. So we get, we do get 144.39. Yeah, that's correct. Okay. 38539. Both are the same. That's fine. All right, so that is definitely correct. Absolutely, 100%. Does it say round to the nearest thousand? Does it actually say? Thousand or thousand? Oh, thousand. Oh, then it'd be like 24,000. Yeah, thousandth with a th would be 385. That would be correct. But yeah, it's all good. I like the more accurate answers anyway. So it's all good. I'm fine with this. I'd be perfectly fine with this. Yeah. Some like I said, that wording. Yeah. Get down. Okay. All right. So what I want you to do here, Brenton, is to just follow what it says here on the screen. So that I want to be sure that you get this right, because for some reason it's not working on the calculator the way it should. So first, do on your calculator here. Go ahead and do you have a? Actually, let me ask this question here, really quick. Do you have a, basic or graph? Do you have a basic calculator or a graphing calculator, Brenton? Really quick, because then I can tell you the instructions there just based on depending on which one. There we go. Yeah, no, I totally understand that there's a delay. Okay. All right, so follow me here with this one, all right? So if you have the TI-32. So when you hit parentheses here, 430,000, because the TI-32 I know has parentheses. So 430,000 times 42. So just go ahead and do that on the calculator first. You're going to get a pretty big number, so which is fine. All right. Now, once you have your answer there, you should have on your calculator, there, you should have this. Is that what you have on? Oh, yeah. Is that what you have on your calculator there, Brenton? Okay, great. Okay, next I want you to hit divide. So it says this. Answer divided by, and then in parentheses there, I want you to go ahead and hit 7.48 times 100 and close parentheses. You must use parentheses here. Uh, we're just making sure that we get this down on the calculator. There's a lot of things on the calculator we'll be looking at later on, so I want people to get kind of familiar with the calculator there. I know this seems like no, I'm seeing like I'm being a pain there. A syntax error. A syntax error. What? Okay. Let's try this again. Why don't you put this in the calculator? Make sure you're using the buttons correctly. All right? Don't go too fast. Why don't you put this in the calculator and tell me what you get? Again, the answer that you should get here is... Yeah, I understand that. That part I totally get. I know there's a delay in the stream, so... Bretton, what are you entering there? I don't understand what you're entering in there if you're getting the answer there. You have to hit... I'm a little confused what you're trying to enter in there. Because you shouldn't be getting answers that are that wildly off. Like, I'm a little confused. So go ahead and put in 100. Let's go ahead and put this number in. All right. Hit the division key. Yeah, wait, that's not them. There. Let's try that, and hopefully that works. Hopefully that works. Move here to this next one. Go to a certain page here. Actually, no, not that page. Go to another page. Let me go to that one. All right. Yeah. Let me know what you got there, Brendan, once you got that. There we go. Now you got it. Perfect. All right, great. I hope you get more familiar with the calculator there, Breton, so that way you'll be able to enter it in properly. The calculator has very particular ways it likes things entered. So, again, maybe you've had a little bit of an issue in the past. So again, this is good in a way because now you can see what you'll need to do in order entering in those numbers properly there. So yeah, the calculator is very particular on how it wants things entered. So yeah, that's why you have to be very careful. Is there a class for the calculator? There's not, unfortunately, a class for the calculator because it's just basically you take it as it comes. So we have well, we did have calculator workshops, but those calculator workshops are more with the graphing calculators, unfortunately. But that's why I'm here to kind of help you through the process about how to enter that into the calculator. Yeah, YouTubing it, yeah, as Jasmine says, will be fairly helpful here, especially with your type of calculator there with the TI 34 there. So, like, I know I've worked with the TI 34. Like, it's not a hard calculator to work with. It's just takes again, working with the calculator there just takes a little bit of time. So yeah, be sure to kind of brush up on a few things if you're having issues with your calculator or you're not sure how to use some of the functions there. Okay, about how to enter in certain calculations. So yeah, just be on the safe side there and just kind of gear up here. But I'm glad that we did this to get here together because at least you'll have a good idea about at least one way to do certain problems here. So and how to enter stuff in. You could see how particular it was for you to actually entering in the numbers there. And we're going to see more examples like that. So it's going to be rather important. So getting comfortable with it now will certainly be helpful later. All right. Okay. So now that we got all that squared away, very good. We're going to go ahead and look at the last section here for today, which is going to be section 5.3, which talks about the metric system. Okay, so the metric system here is used by most every other country in the world besides us. So yeah, how does the metric system work in comparison to, say, the standard system that we're used to here? Okay, so essentially the metric system kind of works like this, and let's at least talk about how it works. Now, we'll we'll take a look here in the middle. In the middle of the process, in the middle of the metric system here is 1. So we'll call this, there's a 1 here. Now this 1 here could refer to any type of unit within the metric system. Units that you've heard before, such as grams, such as bytes, okay, such as things like that are all metric units, meters, liters, okay, those sort of things would be, say, at a base level here would be underneath 1. So that'd be like right in the middle. We would say let's call it meters here, since most people are familiar with meters in some regard. Maybe not completely, but still. Meters here is right here in the middle. This is going to be our set standard here. This basically is going to be a suffix, okay, to our other. Now, suffix is just a nice word for basically saying kind of after, kind of the second half of the word there. So, now, if we take a look at this chart here, now let's want to actually reference the chart here for this. This chart here that you see talks about the metric prefix that we put before the actual unit itself. So, for example here, a centimeter, okay, there are actually two parts to that word. Centi means 10 to the minus 2 power, or 0.001 of a meter. So if I go here, let's go back to our, um, so we go centimeter. So this is like, if we go to the left here, this is 10 to the minus 1 here, and then this is 10 to the minus 2 here. So this is centi. And then our base word here is meter. So centimeter. So what does this also show here? This also shows underneath the metric system, since it works off of a base 10 type of system here, basically it would be 2 away from our actual regular units here. Essentially, this basically justifies why we have 100 centimeters, or 10 to the second power here, is equal to 1 meter. Because it's 1, 2 away from meters. If you take a look here at the next one over, say 10 to the minus 3, all right, you'll see that 10 to the minus 3 is millimeters, okay? So again, we have millimeters. So we have millimeters, for example. So that's where we get the idea of what's millimeters here. So, how many millimeters, how many millimeters in a meter? Again, you see 1, 2, 3 away from meters here. So that's why you can actually say, well, 1,000, millimeters is equal to 1 meter. This works with any such thing, right? Let's look at the other direction here. So you can also go the other direction, kilo, like kilobytes, okay, or kilograms, okay. We often say kilograms, kilobytes, okay, of data. No, that's not a lot, obviously. Megabytes, right? Megabytes, okay. We usually go megabytes, gigabytes, terabytes, okay. Those are the most common ones here, but they also have a multiplier associated with it. Well, how many bytes in a kilobyte? Well, 1,000 kilobytes is 1,000 bytes is equal to 1 kilobyte. So let's go with, like, let's say this was grams, for example. Let's go with grams. If I say this is grams, for example, and I said, 10 to the third here is equal to kilo, that's the prefix here, then I would say, okay, well, how many grams in a kilogram? Now that's 3 spaces over, so that's 3 zeros. So 1,000 grams equals 1 kilogram. All right. All right, so that's basically how the metric system kind of works. It's a very simple base 10 system, just using some prefixes with some units, and then we just kind of just plop it on, and then that's about it. That's all you got to do, essentially. Um, Now, most of the time we kind of figure out, kilometers, and we figure out millimeters and kilograms and centimeters and millimeters. Okay, now most of you have probably heard of those before. Milliliters, if you've done chemistry, liters and milliliters are pretty common in chemistry classes. Okay, like, hey, I gotta fill this test tube up with X, 5 milliliters of liquid or whatever. Or again, okay, the weight of that is 1,000, is, you know 500 kilograms or whatever. Maybe you've heard of that before, and some random passing. So again, there are things that you probably heard in the metric system, maybe not used all the time, obviously, um, but we do use it quite a bit, especially for like medicine. Medicine, we use milligrams, right, for medicine, right? Your doctor prescribes 250 milligrams of medicine A, okay, to help you relieve your sickness or symptoms or whatever. Okay, so um, nobody caught the news today, though. They might have found an effective vaccine for COVID-19. So, cross your fingers for late November, everybody. Cross your fingers for late November. Hopefully that will come to pass. So, that'll be good. It's currently 90% effective. So, all right. Now, how does it work in general here? Now, if we could take a look here, there's some regular lengths here, like 1 centimeter is 10 millimeters. 1 meter is 100 centimeters, 1,000 millimeters, as we pointed out here. Kilometer is 1,000 meters, okay, for example. There is a little bit of a conversion chart here for common ones. There's a lot of different common ones that you can certainly look through. And they have it on page 323. I'm going to go to page 323 here. So just for reference here, once again, there's a little bit of a chart here. Again, I'm not going to expect you to memorize some of these, all these. Again, they just work off the basic metric system here. Um, as you see here, one of them I know is, some of them you haven't really seen too much before. So here again, 1 liter is 1,000 cubic centimeters. That's pretty brand new. 1 cubic centimeter is equal to 1 milliliter. Okay, 1 milliliter is equal to 1,000 liter. 1,000 milliliters is just a different way of writing milli. So as you can see here, not not too hard. This one here, I know that we don't use this too often. This is for area. I believe this is, man, what was that again? I think it was 1 hectare. 1 hectare is equal to 10,000 square meters. That's I think that's hectare, or hectare. Yeah, so hectare. Again, that's a metric unit here. Again, we don't use that too often, but yeah. I mean, it is still a unit there. So, all right. In any case, though, we'll also look at Celsius and Fahrenheit. That's also a thing there. So, all right. More of the next section, though. Okay. Let's take a look at several questions here, and let's see how we can work them out. Okay. All right. So this one here is going to be rather. This one here is actually one of my favorite questions here in this section. So let's look at number 6. Number 6 says, in Taipei, the Taipei 101 building in Taipei, Taiwan, is 509 meters tall. Its elevators are the fastest in the world, rising at 60.48 kilometers per hour. How many seconds would it take for an elevator to rise the entire height of the building non-stop? Okay. So, excuse me. We want to figure out how many seconds it would take for us to go ahead and get to the top of this building here with these really fast elevators. That's really, really fast. So we have a building here that's 509 meters tall. And these, have a 509 meter tall building. Put that over 1. And we go at 60.48 kilometers per hour. Okay, that's the rate of the elevator here. 60.48 kilometers per hour is the elevator here. We want to figure out how many seconds it's going to take to get to say the top of the building from the bottom. All right. So what I need to do here first in this particular case is I have a 509 meter building. Okay, that's how many meters the building is. It's very tall. Okay, but I need to have it in kilometers so that way I can put it in terms of kilometers here. So let's answer the question here, looking at our little chart, okay, from before, or again referencing somewhere in that chapter. How many meters in a kilometer? How many meters in a kilometer? Good, 1,000. That's right. Now, so we have 1,000 meters in a kilometer. All right, let's write that down. So where should I put meters here? Should I put meters here on the top or should I put meters here on the bottom? Where should I put those 1,000 meters? Should that be on the top or the bottom? On the bottom, good. So we want to have meters on the bottom here specifically so we can cancel out the meters units, just the same way we did in the last unit, right? We want to say, okay, hey, you know what? Let's get rid of meters, so let's have one on the top, one on the bottom, so we can cancel them out. Now make sure we have 1 kilometer here on the top. Okay,